Thank you. So nice to see you all here, and let's hope that you will have a still little bit patient before the lunch, so that's this difficult time before lunch. But anyhow, so my name is Sampo Pilli-Sihvola, so it might be difficult to pronounce, but it's also difficult to pronounce the Lithuanian names, so I can cope with that. So I'm a senior manager in Peikko. I have just started there in the last year, so not the big career in there. My career has been started in the BIM side. That same number was mentioned a year, 2006, in the earlier slide. So since that, I have been working with building models and building model information related topics. So before going to the actual presentation, so a few words about the company which I work, so Peikko. So many of you might already know Peikko earlier. So Peikko is a family-owned company founded in 1965, located headquarters in Lahti in Finland. We have factories in 12 different countries. One of them are here in Lithuania, in Kaunas. We have sales offices in 34 countries globally. So globally we have also more than 2,000 employees. So plenty of new colleagues for me. And the last year the turnover of Peikko was 255 million euros. So what Peikko does? So for Peikko is an innovative company. So right things matters. So that CO2 calculations has been mentioned there in the earlier slides as well. So Peikko is taking that in a serious way. So we have been able to produce a product which is decreasing the CO emissions by 50%. There was also the mentioned timber structures. So we are working with those as well. So with our Delta Bim product, we are able to provide a combination with the steel and wooden structures quite efficiently. Then there is also the kind of like new topic, which is the Circulate Economy. And that means in Peikko way of working so that those precast connections which we are providing, they are able to be disassembled. So meaning that the elements could be used in the future in the other building if needed. So Peikko is an innovative company, and it's also staged to be a global forerunner in several states. So in slim force structures, wind energy applications, and the connections between the connection technologies for precast and cast in situ constructions. So, like I said, that I have been several years, so more than 16 years, in a BIM world. So actually this digital concept were mentioned in the earlier slide as well. I have a few more information in the later slide, but I wanted to take this one project, which I actually showed here in Vilnius about 10 years ago. At that time, that was a kind of like a high-end BIM project. There was IFC models from the architecture, from the structural designer, from the MEP, and also the electricity was modeled fully in the model. At that time, there was a discussion about that, is it really wise to do the 3D model? Why we are not able to use the 2D as we have done earlier? How long does it take? What is the worth of doing that? Nowadays, I'm not hearing that kind of statements too often. So kind of like it has been accepted that there is a benefit and value. So some common concept, which at least two of those I have seen in the earlier presentation. So BIM, digital twin, LOD, level of details. So actually BIM is used in several cases, but actually what comes to the Wikipedia, so BIM is a process. It's not the model, it's not the kind of like a software, it's a process. It contains different kind of technologies and also the content. Then the digital twin, so it's a concept. It's a concept of physical product, digital product, and the connection between of those two. Then level of details, especially in the UK, level of details has been utilized in heavily in the construction, and it's giving the information of model complexity in 3D model representation. Then if we go to the Bim Life Cycle, and we're thinking about the project, though this is quite familiar for most of you who are in the construction business. So you will get the input data from the, for example, in the architecture, and this is now thinking about from the structural point of view. So you will get the input data from the architecture, then you will start to do the construction and the structural model. There might be the FEM design solutions utilized in a calculations. Nowadays, the CO2 calculations are done in the really early phase of the project. There might be some iteration even between the different solutions. Also, the algorithmic modeling has been used in many cases. So then the information evolves. So the models or the model information is transferred to the fabrication purposes. So different information which is needed in a fabrication, for example, material size and strength of the materials. Those are transferred automatically, digitally to the ERP systems in many cases, and then the fabrication is done. Then next evolving stage is the logistics. So those need to be transferred to the site. So again, the information which is put in the model already in the earlier phase, so weight, size, and also the location, so the distance from the factory to the site, and also the schedules when those need to be delivered, can be in the BIM information. Then on the site, again, similar kind of information needed there. Size, weight for the lifting, and the storage area, so scheduling of the project all in all, and site planning can be done with utilizing the BIM information. Many cases the project ends and then also the life cycle of the BIM models ends. But more and more, especially in the bigger project, you are seeing that the facility management is also utilizing the BIM information. So maintaining the project in the future, there might be some additional information which will be collected during the life cycle of the BIM in the building, or there could be also the usage information. And when the building's life cycle is going to be end, so then the same BIM information can be utilized in a various way. So if it's demolished, so then there's a recycle plan. If it's circulated, the plan for that one. And then the rebuild when it's circulated. And from the bottom you can see those pluses, and in the earlier presentations there was also mentioned that the information is gathered and there are solutions which are gathering the information to the database or several databases. So information is not maybe in the same place, but it's gathered and it's utilized in other phases. Then if we take a look at the case Terminal 2, Helsinki-Vantaa Airport extension, so how the BIM is utilized in that project. So Peikko was also involved in that project, and you can see that part of the canopy there, which was the steel structures behind those wooden structures, were manufactured by Peikko. So if we take a look at the project itself, so it was a BIM project, Alliance project, and we have a short video about the project to show. Okay, there was plenty of project parties in this project. So the client, Finavia, was the owner and is owner of the Helsinki Airport, and the main structural contractor, main structural engineer office was Rambo, contractor was SRV Rakennus, and then there was architect offices, Ala and HPK. And then it was when it was a BIM project. Nowadays, there's in this kind of big project, you are finding also BIM coordinators, and the Gravikon Oy was the BIM coordinator in this project. So the project is large, so it's a 103,000 square meters. Investment was a 1 billion euro. There was a new 16 new wide-body aircraft spaces built on the new extension, 4,800 new parking spaces, 2.3 kilos supporting steel structures in that roof structure, and 6,000 square meters of wooden ceiling. So it was a major project, and BIM was the kind of like a most beneficial part of that to get it done, and done it in even earlier than it was scheduled. So some technologies and resources which was used in the project. So there has been a discussion about the models. In this particular project, there was 400 models, so it's a lot of models. And of course, all of those models were not the kind of like a initial, or let's say that there's initial models, and some of the models were then being published and will be then continue to its usage in the later phases as well. In active mode, this project contains 150 engineers, so a huge amount of engineers was also involved in the project. More than 30 different softwares. Some of them are seen there as a logo, and some of them has been also mentioned in the other project as well. The BCF was utilized in a collaborational format, so issue management format. IFCs were used as a published models, so those were published in whenever needed, and then there was collaborated, and the Gravikon was combining the models for the common meetings with different disciplines. There was used also the big room, which means that all the disciplines were working in the same space, which of course enabled the clear and easy communication between the different disciplines during the project. Lean method and the task planning was used also in the project, and algorithm modeling was used for that quite nice looking roof structure. Then the statuses of the different phases, so the status of the design and detailing, status of the fabrication, status of the construction, that kind of status was shared to the different disciplines throughout the whole project. So BIM information. So there you can see the roof structure, steel structure. So some of that steel structures were manufactured here in Lithuania, in our Kaunas office. Then there was those Delta Bim steel frame as well, which were designed, modeled, and fabricated, and also installed by Peikko. So a lot of information needed in this kind of project. So in this project, like in many other projects as well, the information is scattered, as we have seen also in the other project as well. So I borrowed my former colleague Leif Granholm's presentation, where he states that no such thing as the model. So there is no one model. There are several models, and there is several methods used there. So there's a different viewpoints to the different use cases, and here's the example that, okay, what kind of use cases there could be. So if there is a floor, so when it needs to be detailed, and for example, in this case, if it's made from the, for example, Holocaust slab, so then you need to have a detailed information there. If it's in an engineering phase, it might be that you are just having the different phases of the project, and you are, for example, doing the scheduling for that particular floor or place. And in the architectural phase, it's enough that you have the square meters and also the leveling of the floors. So different use cases, different models needed and utilized. There was also, in many earlier presentation, you were seeing that there's several different softwares used in several phases. And in the last presentation, so Estonian government project there. So there we can see that this kind of like a shifting from the creation part is going to more to the data consumption or focus in there. So there is already those desktop applications, several of those which are actually the creating part. So there's architectural, structural MEP models which are done with mainly desktop applications, and then there's a published models. And those published models are then used and shared with publishing platforms in an open format, which and then the information can be utilized with the new solutions, which I at least have seen that there's a huge amount of new solutions for the data consumption. So the data consumption, I would say that in 2006, 2010, the creation part was the 80% of the data usage. And now I would say that the consumption is 80% of the data usage. So why it has changed like that? So it means that there's now easier ways to model. You saw those modular buildings there, so it's easier to make the easier and faster make the creation part, and then you can focus to the utilizing the information, which is actually more valuable than the actual 3D model itself. So there is plenty of different kind of solutions. So mobile apps, different kind of web apps, as we saw in the last presentation. Machinery can utilize the information. There's robots, there's drones, which can also see and use the information. So world is changing, and the digitalization is also taking the part of that change. So some conclusions of the life cycle. So life cycle of the BIM model depends on the project. So if you have a small project like that residential building which I showed in the first phase, so mainly it was made for the purpose of to get the needed document for that project. Then life cycle of the BIM models depends on the content of the model as well. So if we know in the early phase already that, okay, this model will be used after the building is ready for the facility management or safety planning or whatever needed, so then the life cycle is longer. And life cycle also depends on the use of the model. So, for example, that Terminal 2 case, so the Finavia is demanding that they will get all the models from the Terminal 2. So they are utilizing that model information in the future. That kind of place like an airport, it's always changing. So they are utilizing the same information, they are enriching they are updating the data, and they are publishing the new updated data as well for their internal purposes. And the life cycle of the BIM models depends on the owner of the building. Like there, the Terminal 2, so the owner, if the owner sees the value and the benefits of those building information models or building information all in all, so then it has a longer life cycle than in a normal project. Then I have gathered some links for you to look. So there's links to that project which I showed and some other research projects which are related to the BIM processes. So thank you from my side, and let's see if there's any questions.
Thank you, Sampo, for an inspiring presentation of being at the airport. It's amazing. So one question before the lunch. So what do we need that the life cycle of the BIM model would become continuous?
Yeah, I would say that the last statement in that conclusion, so the owner if the owner sees the benefit from the model, so, and as we can see from the Estonian example, that okay, there's a government who is willing to have those models and see that the information in the model is valuable. So then the life cycle will continue and that will be utilized much more efficient than it's done in many cases.
Thank you for the answer. Thank you, Sampo, for the presentation.
Thank you.